Today I wanted to discuss yet another viral story in regards to another invention that potentially is going to change the human society. Or is it? Is this just another hype like LK99 room temperature superconductor? And the story we're talking about was reported by a lot of media out there. It was in regards to this battery that you see right here from a Chinese company known as Betavolt. And essentially what the proposition here is a battery that's able to run continuously for over 50 years without the need for recharging, able to operate in very low temperature conditions, and is also practically unbreakable. Too good to be true or possibly real? Well, just to give you a bit of a spoiler, the answer is, I guess, a bit of both. And so, hello wonderful person, this is Anton. Let's discuss this new proposition and this new idea in a little bit more detail, talk about the facts versus fiction, and I guess come to a conclusion if this is really going to change the world anytime soon, or if we have to maybe wait just a little bit, until I guess fusion comes out or something. And to start, let's talk about the theory behind this, and talk about how, hypothetically, all of this would work. So based on what you see right here in this picture, we can already tell what's inside. This is a nuclear battery containing nickel-63. And as you can see right there, it says radioactive material. And so this is a nuclear battery, a tiny nuclear battery, approximately this big, that generates all of its energy from nuclear fission. But in an entirely different way from a nuclear power plant, or even from what we refer to as RTGs, or radioisotope thermoelectric generators, which have been used by various agencies including NASA for many decades. Now this is SNAP-27 from the Apollo 14 mission, but when it comes to long-term nuclear batteries, RTGs right now are basically the workhorses. Although here, as you can see, they are relatively large in size, and that's actually because they function in a slightly different principle. Here they use nuclear materials to basically create heat, and it's this heat that is then used to generate energy. Normally through what's known as the Seebeck effect, also sometimes referred to as the Peltier effect, or even using some kind of a Stirling engine that basically uses the heat to generate pressure and to then drive some kind of a turbine. But in this case, what's proposed in this new battery is something entirely different. Although before I talk about this, a super quick side note. A side note in regards to how we usually generate electricity on planet Earth. Even though it might look like we have so many different ways to generate electricity today, be it renewable or non-renewable energy, underneath the hood, they all work under the same principle. And mostly three separate principles. Things like generators or things like turbines basically work with the principle known as the Faraday's law of induction. Essentially, by moving a magnet inside some kind of a coil, we can produce electric current just by using physical motion. And so when any kind of a turbine spins, it produces electricity. Now I'm obviously kind of oversimplifying this, but in essence, anything from wind turbines to any kind of a nuclear reactor essentially operate using this method. They normally heat up water in some way, with the water steam then driving the turbine, and the turbine using the motion to generate electricity through the magnetic field. Today this is pretty much the most common way to generate electricity, with the second most common way being electrochemistry. And that's basically batteries. There are different ways to generate electricity through chemical reactions, but because of the convenience of storage, today electrochemical reactions are really mostly used for energy storage. And then we obviously have photovoltaic effect, or solar panels, using the energy from the sun, or photons, to excite electrons inside certain materials and then generate electricity that way. But apart from these main methods, there are some additional methods that we're going to be discussing in a separate video sometimes in the future. So yeah, subscribe if you want to learn more, that do actually generate electricity, normally in much smaller amounts, but using completely different techniques. And it just so happens that this is exactly what's proposed in this battery as well. Betavolt is using a really intriguing method that unfortunately none of these articles describe in a lot of detail, but has been actually researched for, I think, like 2 decades now. This is not a new method at all. And it is a method using radioactive materials. But here's the important part. This method was originally proposed as a potential solution to the excess of radioactive waste on the planet because it actually allows us to use waste to produce extra energy. And that's the brilliant part. This physically works, we know it works, it's been proven many times, but it just hasn't reached that peak yet where people are ready to accept it and start using this for devices around us. But let's actually talk about how this works and what this is. If you were to look inside of this, you would actually see something that resembles what's known as the Schottky diode. Basically your typical semiconductor diode that allows the current to flow once a certain voltage is applied. But this particular technology is known as the diamond Schottky diode. In essence, it uses a really intriguing discovery from something like 2 decades ago, when researchers discovered that if you were to place a diamond next to certain types of radioactive materials, it actually starts to generate tiny amounts of electricity. And the way it works is really simple. Diamond is essentially an extremely structured carbon. But when these crystals of carbon start to interact with certain extremely energetic electrons, which we usually refer to as beta particles, or basically high-speed electrons or positrons emitted through radioactive decay, at this point, these electrons disrupt the diamond structure so much that it physically starts to shift electrons inside of it, generating electric current. Or just to rephrase this, these very high-energy electrons that we refer to as beta particles interact with carbon inside diamonds, inducing electric current as a result. And so technically, any kind of a nuclear waste that's able to produce beta particles can physically produce even more energy if we put it next to diamond cells. And so by turning this into a kind of a sandwich, or basically by doping diamond structure with certain radioactive elements, it becomes possible to produce this diamond Schottky diode. And so the structure of this Chinese battery kind of looks like this, except that this picture is not from that Chinese company. It's from Technological Institute for Super Hard and Novel Carbon Materials, located somewhere in Russia. And their prototype looks something like this. And this was from 2018, 6 years ago from when I'm making this video. Then we have another one from 2016, this one from University of Bristol, that even comes with a cute animation explaining how this is going to change the world in the future. Although in this video they also propose using carbon-14, another radioactive element that's technically going to be even more efficient than nickel-63, and is also widely available as a byproduct in a lot of different graphite rods used in many different nuclear reactors. And there are actually quite a lot of studies even from the early 2000s basically discussing this idea of diamond Schottky diodes. With I guess the obvious question being, okay, so after almost like 2 decades now, why is it that we still don't have any of them used anywhere for any reason? And though there is no one answer to all of these questions, one of the potential answers is actually in regards to these early discoveries from many of these papers previously. A lot of these diamonds have to be basically perfect for all of this to work perfectly. And so any kind of a deformation inside or any imperfection inside the diamond crystal is just going to result in either dramatic reduction of electricity production or even no electricity produced at all. At the same time, deforming this battery even a little bit might break it as well. Not to mention the fact that it has to be unbreakable enough in order to preserve all of this radioactive stuff inside. And then there's of course the question of radioactivity. Even though technically these are pretty safe, just because of the reputation radioactivity has today, I don't think a lot of people are going to be using something like this inside their smartphone that they're going to be storing extremely close to their important parts. I mean, I still remember stories about early cell phones and how a lot of people were convinced that radiation from smartphones can actually cause all sorts of disorders, and so I can only imagine what people are going to start saying if there's an actual radioactive element that's going to be powering their devices. Not to mention that even manufacturing something like this would be quite expensive compared to typical electrochemical batteries we use today, and so the economics for this are just not there yet. But on paper, it actually still looks pretty cool. For example, in terms of the actual danger, there is really none. This particular battery uses one of the isotopes of nickel, nickel-63, that's already synthesized today and used widely in a lot of different devices around us. Normally it's used in a lot of different detectors, but the current volume produced are extremely low, so the availability of this particular element is also a bit of an issue. If we were to somehow use this to power every smartphone on the planet, as the press release here actually claims, the production of nickel-63 would have to be increased by like millions of times, if not more. That's just impractical right now. Nevertheless, in theory, this battery that produces 3 volts and roughly around 0.1 watt of power, if scaled to a larger size or if produced in larger numbers, could power a smartphone for possibly 50 years. With this particular company already proposing their next model that's going to be able to produce 1 watt of power, possibly by 2025. But once again, at least for now, all of this is just talk. This particular design and this particular idea has been proposed previously many times, but still just hasn't happened. Or basically has not reached the point where the production can be scaled so much where we can physically produce a lot of these batteries and make them practical enough to be used in daily lives. And so at least for now, I'm going to assume that this is most likely not going to happen yet. It might happen with that carbon-14 if someone figures out how to do this safely, mostly because we do actually have a lot of carbon-14 available in a lot of different facilities around the planet, but nickel-63 maybe not so much. Interestingly though, the decay of nickel-63 turns it into non-radioactive copper. And so at least in theory, these batteries would be super safe even after they expire. So yeah, on paper, this looks amazing. Just maybe not in practice. And so does this mean that this technology is just not going to happen? Yeah, no, not at all. A lot of you are probably aware that this technology already exists and does actually work with slightly different principles. Because the idea of powering things using beta radiation was originally born back in 1953. And we do already have so many different beta voltaic devices using this principle to generate energy. For example, some of the earlier pacemakers used elements like promethium to create beta particles and then trigger the diode in order to produce a tiny amount of current needed for some of these devices. And so even today, some of these devices still use things like, for example, tritium, an isotope of hydrogen, to generate small currents. But here the problem is that the currents are just really tiny. It will be very difficult to scale this to something like, for example, a smartphone. But the diamond Schottky devices technically can scale. And so once again, the theory is still solid. And for all we know, maybe someone in the future figures out the practical way of producing these and using them in real life, thus moving us away from lithium-ion batteries and towards something that we technically have a lot of out there. A lot of nuclear waste, that is. But it's definitely not happening anytime soon. But honestly, I just wanted to talk about this because this is a really cool technology. A technology that, in theory, could take us to a completely new level when it comes to using electricity. This would be usable anywhere on Earth, it would be usable underwater, in space, and can physically function for decades without ever needing any kind of recharge. I mean, just look at the Voyager probes. Even after 50 years, they still function. And so even though there's still a lot of fear about nuclear waste and nuclear technology in general, hopefully we overcome this and start using it more again. Especially because in this case, it technically uses nuclear waste, something that we do want to get rid of some way. But anyway, on that note, check out some of the links in the description. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support the channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.